We are bringing to market an innovative bio-inspired sensor of volatile compounds that gives building operators confidence in the gases indoors and also provides them guidance in achieving healthy indoor air quality. Our sensor is accurate and highly sensitive thanks to its advanced air sampling and data processing methods to achieve higher reliability.
According to the US EPA, indoor air can be 2 to 100 times more polluted than outdoor air. Repeated exposure to gases emanating from paints, wallpaper, cleaning supplies, and cooking has been linked to increased incidence of lung cancer, asthma, cardiovascular disease, as well as cognitive and developmental effects. The problem is that currently there are no affordable and accurate sensors of the chemicals in our air, making ventilation and air purification a guessing game, costing lives.
To solve this problem, this team has turned to nature and biology to gain inspiration on how to improve our senses. Dogs are a great example because they can smell down to parts per billion and actually from miles away.
That's why we use dogs still in very difficult tasks for rescue, sometimes in airports, and even these days to detect diseases. But dogs cannot do it for us in every setting. So that if we develop, and this is what we're doing, a technology that takes this natural ability to smell, we will solve the problem of chemical sensing much better than sensors that exist today.
The sensors in use today are simply unreliable. Existing indoor air quality monitors not only respond to fluctuations in temperature and humidity, but also fail to distinguish between chemicals of varying toxicity. They don't allow you to correlate that signal to what's happening in your house. The sensors are Bioinspired. It uses sniffing sequences to be able to distinguish these compounds based on their unique adsorption and desorption patterns and provide real-time gas predictions.
Indoor air quality sensors can really be beneficial to the building industry by identifying specific indoor air quality problems, which can help reduce serious health issues. And the US Green Building Council, a historic trendsetter in the building industry, has recently recognized this urgent need by offering up to 12 points out of the 44 likely needed for certification in their new Lead for Operations and Maintenance rating system. And those points are specifically for continuous indoor air quality monitoring. I think there's going to be a time when we look back at buildings today and think that it's so weird that we had no idea what was in the air. We're so used to nutrition labels now on our food, and it seems strange to even think that we would eat packaged food that we didn't know what was in it. But we're really ingesting a lot of chemicals through the air that we breathe, and so it's high time that we know what's in that air. House Zero is called a house, but it is the headquarters for the Center for Green Buildings and Cities at Harvard. It's a living laboratory where researchers can try out different strategies, new technologies for building design. It was built with very low emitting materials, so the background emissions are very low. Also, it has a HVAC system that can be automated, even on a room-by-room basis, so that's an ideal testbed.
We're a multidisciplinary team that involves engineers, material scientists, computer scientists, designers, architects. This collaboration is important because we're looking at completely different aspects to develop this unique, innovative technology. We're partnering with Metalmark Innovations, the company that is developing air purification systems that will be triggered to disrupt volatiles based on the sensor data. We do believe that we can bring to the market a technology that is much better than anything there and can solve the problem of air quality.